Hello, my name is Brandon Miller, and this is my presentation for a Network Support Management class here at OSUIT. For this video, I have chosen the Chapter 8 topic of Virtual LANs, also known as VLANs. I'll be covering what VLANs are, why they are important to modern organizations, what VLAN trunking is, and how to configure them on Cisco devices, and how to troubleshoot common issues. Before we can delve into the weeds, we first need to understand what VLANs are. By default, all devices on a switch are all in the same broadcast domain as one another. This means that whenever a device sends out a broadcast frame as a package, every other device on that domain receives a copy of that package. If you wanted to control which devices could receive which packages, you would need to set up a physical switch for every domain you need. To avoid this unnecessary waste and complexity, we can use a virtual LAN instead. A virtual LAN allows multiple domains to exist on one switch simultaneously, letting us avoid wasting resources and streamlining the network. Now that we know what VLANs are, we can look at the reasons why we'd want to use them. To start, there are several security benefits to using VLANs. For example, if you have a dedicated legal and financial department in your business, it is best that the information passing between those computers does not make its way to any device that is not authorized to see it. Additionally, you may be willing to sacrifice some speed and responsiveness in order to place stricter and more protective firewall and security protocols on those specific devices. That may not be worth doing for the entire network. Even in situations where there are no security or privacy concerns about where a broadcast frame ends up, there are several reasons we would want to split up the devices into multiple domains anyways. First, we lower the CPU overhead on all the devices on the network by slimming down the number of broadcast packets on each one received. This is especially important on large networks with lots of devices that can be quickly overwhelmed by the sheer number of packets being sent. Second, for organization and management, it is helpful to group different departments and work groups into their own VLANs and make it easier to assign resources to a specific group in the organization. Now that we have a good understanding of what a VLAN is and why they are useful to a network, we can cover some important topics about implementation, like trunking. While VLANs let us avoid needing to use multiple switches in a lot of cases, for medium and large networks, things like the physical distance between devices, large numbers of devices, and network infrastructure overload require more than one switch on the network anyways. And on these larger networks, there is a good chance that devices on the same VLAN are connected to different switches. For example, maybe you have a VLAN for your logistics department and one computer is up in the office while the other one is down in the warehouse. For these situations, we can use VLAN trunking. The way VLAN trunking works is that when it is enabled on a switch, the switch adds a VLAN tag to the sent package. This tag adds a header to the package that indicates to the receiving switch that the packet is meant for a specific VLAN ID, aka the domain. The alternative to this would be using a dedicated connection and port on both switches for each VLAN, which is both impractical and a waste of resources. Before we move on, I would like to quickly go over the IEEE 802.1q standard for trunking, as it may come in handy to keep in the back of our heads. Due to how this trunking standard is implemented, each switch can support a maximum of 4094 VLANs, though standard switches only support up to 1005. Still, this is more than enough for the vast majority of use cases. On each trunk, there is one VLAN that is designated as the native VLAN. When packages are sent to and from this VLAN, no header is added. If either switch receives a package with no header, it sends it to that VLAN. This is very useful when working with devices that do not support trunking, as you can still use the device for the default VLAN without running into issues instead of needing to replace it. While it is all well and good to send data between devices on the same VLAN, there are still plenty of cases when we need to communicate with other devices all over the network. In these cases, we need to understand how we can communicate across different VLANs. For layer 2 switches that communicate based on MAC addresses rather than routing with IP addresses, VLANs effectively break off a chunk of the switch in order to make an entirely different switch. This means that there is no way for the switch to transfer data between the two by itself. In fact, you could argue that this is the entire point of a VLAN in the first place. To get around this, we need to route the package either by using a router or a level 3 switch. This is done by using the IP addresses of the devices and the fact that different VLANs also use different subnets as well. By sending the packets to a router on the network instead of through the switch, we bridge the gap created by VLANs, allowing for communication. Now that we have a good grasp on how VLANs communicate both inside themselves through trunking, as well as between one another with routing, we can go over the configuration of these concepts. These configurations will be for Cisco switches running Cisco IOS. To start, we must configure the switch to support simple VLANs where there aren't any outside devices, then we can configure trunking. The first step is to create the VLAN by using VLAN ID command in the global configuration mode. You can also use the name command to name the VLAN whatever you want, though do note that you will still use the VLAN ID for configuration. Preferably, use something descriptive when naming, like finance, classroom 123, dorm 4, etc. After creating the VLAN, add each interface that you plan on using to the VLAN with the switch port access VLAN number command, replacing that number with the VLAN ID. While here, you can also configure the switch mode with switchport mode access command to make it easier, so make it so that the port does not use trunking at all if needed. It is also good to know that you can create a VLAN by trying to configure an interface to a VLAN that does not exist, which can speed up the VLAN creation process. Now that we have our VLAN, we can configure trunking so that other devices on different switches can be added to the VLAN. To do that, we need to check two things first. First, make sure that the mode is not set to access so that you are able to trunk. This is fairly easy as you need to manually enable access mode on a port for it to be active. The second, however, is unique to Cisco switches. Cisco uses a unique protocol called VLAN Trunking Protocol, or VTP, that lets switches advertise what VLANs are on it with other devices on the network. While there are some uses for this, it is industry standard to disable this for security and overhead reasons. To do so, simply run the VTP mode off command in the global configuration mode on each switch. With those two done, we can actually move on to configuring trunking. For simple and static trunking situations, the way to enable it is remarkably easy. On each interface, set the mode to trunk instead of access, and you're all good. However, we can delve much deeper into the trunking configuration. The first of these is setting which type of trunking you want to use. By using the switchport trunk encapsulation command, you can decide between .1q, which is the industry standard based on 802.1q, ISL, which is Cisco's older standard, or set it to negotiate, which will use dynamic trunking protocol on switches that support it to communicate between one another on which standard should be used. The second thing to configure is whether to use the dynamic desirable and dynamic auto modes rather than the simpler access and trunk modes. These modes let switches determine whether they need to use trunking, with desirable switches initiating communication and auto switches waiting to receive negotiations. Last is something minor but quite important. For IP telephones, which are very common in just about every business nowadays, configure the port and access mode first, then afterwards use the switch port, voice, VLAN ID in order for the device to use trunking features despite being an access port. This is because most IP phones have a built-in switch that the PC will use instead of having a dedicated line going to the switch as well. And the fact that it's an industry standard to have the PC and the phone on two separate VLANs. This is why we configure both a data VLAN as well as a voice VLAN. As you can probably guess, there are a number of things that can go wrong with VLANs and trunking, so I want to cover a couple of the things we can run into. First is making sure that the VLAN you are trying to connect to is both exists and is shut down. To check if a VLAN exists on a switch, run the VLAN number command in the global configuration mode, replacing that number with the VLAN ID. If the VLAN does not exist, add it to the switch as explained earlier. Next, check if the VLAN is shut down or not by using the show VLAN command to list all known VLANs on the switch as well as their current configuration. If under the status header the VLAN reads ACT/L shut, it means that the VLAN is shut down. To enable it, use the no shutdown VLAN number command just like you would any other interface on the switch, again replacing that number with the VLAN ID. Another common issue is mismatching the trunk modes when configuring trunking. To avoid these types of issues, make sure that, if we're using dynamic modes, that one of the switches is configured as desirable, as if there are only auto switches, trunking will never be negotiated between them. If you do not know what mode your switch is using, you can use the show interfaces switch port command to check the mode. The next troubleshooting thing I want to cover is why a trunk will not forward traffic for a working VLAN. First, use the show VLAN interface ID trunk command to look at the very end of the output. There, we can see what VLANs are currently recognized and allowed to forward data across the trunk. If you do not see the VLAN on this list, make sure that the VLAN is allowed on the VLAN list if configured, that the VLAN is active and exists using the previous troubleshooting method, VTP is disabled and not pulling any shenanigans with pruning and other associated issues, and lastly, the trunk is in STP forwarding state in the VLAN if the network is using spanning tree protocol. These are the most common issues we'll run into when troubleshooting this particular problem. Lastly, make sure that both switches on either side of the trunk have the same native VLAN configured, as this will cause cross-contamination between the VLANs, which, as we know, defeats half the purpose of a VLAN. I hope that you now have a better understanding of the concepts of VLANs and trunking, how to configure them, and how to troubleshoot the common issues that arise while working with them. This has been Brandon Miller, and thank you for your time.